Okay, yes. So we said if we want to find the overall order of your reaction in this part B, we said we look at the unit of your rate constant, We said if the units, we just add them, right? If they have the same sign. If they have different signs, you subtract. So here we add minus one. They're all minus one and minus one. So we just add them. One and one become two. So this is a second order reaction. Now, the next thing is determine the activation energy, and we have been given temperature 1 and temperature 2. So basically this is going to be T1, and it's already in kelvins for us this time, and this is going to be your K1 rate constant. Then here this is going to be your T2, and this is going to be your K2, and you're going to use it II in this one. Ln K2 over K1 is equal to EA over R, then 1 over T1 minus 1 over T2. Remember that. Okay, if it's K2 over K1, it's T1 minus T2. You flip. So this is going to be it. What you are looking for is activation energy. First, you find answers. Take this to the other side. It will divide, and then you take this R to the other side. It will multiply. Then you get your answer. So it will be ln. What is my K2? 6.4. Okay, ln of 6.4 times 10 to the negative 3 mole to the negative 1, second to the negative 1, all divided by K1 1.25 times 10 to the negative 3 mole per mole per second. Okay, and this is all equal to EA over R. We said R, you get it at the last position there. It is 8.314 or something like that. Let's go. You go to the very last page here. 8.314. Yes, 8.314 joules per Kelvin per mole. Okay, and this is going to multiply. Remember, it's going to multiply the 1 over T1. 1 over, what's my T1? 250 minus 1 over T2. What is my T2? 340 over minus 1 over 340. Okay, and this is 1 over kelvins. You get your solution. So basically we can now solve it. So we'll first say, I'm going to say 6.4 exp. Let me put it in the calculator. 6.4 exp. Oh my gosh, what's happening? All right, I fixed it. Let's have it. I'm saying 6.4 exp negative 3 divided by, I'm really pressing 1.25 so that I don't make a mistake, exp negative 3. I got 5.12. So ln of 5.12 is equal to, in here I can say, open bracket, 1 over 250 close bracket minus open bracket 1 over 340 close bracket. This is going to be equal to 9 over 8,500. Okay, so it's going to be EA over 8.314 joules per Kelvin per mole. Okay, multiplying by 9 over 8,500. Okay, like this, 8,500. Then we'll take the fraction to the other side. We have ln 5.12. Okay, 5.12 multiplying, now it flips, 8,500 over 9, then times this 8.314 comes again, so it will be times 8.314 joules per Kelvin. Okay, and you are going to have your solution of EA, which is going to be in joules per mole. So you would say, here I have my 9 over 500. Okay, I'll say this is equal to, I'll say 1 divided by answer. Okay, I've changed it. Okay, I've changed it now. Okay, to this, and I say times ln of 5.12. Okay, which is going to be, I got it. Then I say times 8.314. It is going to be 12,000. So my activation energy, wow, is it real? Is going to be 12,823. So I would say 12.8 kilojoules per mole. Okay, that's going to be my activation energy. That's what I had. Okay, something like this. That's going to be my final solution, and that's it. Okay, now we'll see part C.